Hi, this is Austin with Radical STEM Tutoring, and today we're going to find out how fast satellites orbit around the Earth. Let's get started. Let's look at a satellite in orbit 700 kilometers above the surface of the Earth, in an orbital period that takes 100 minutes to complete one revolution around the Earth. And what we want to find is the velocity of the satellite and the acceleration keeping it in its circular orbit. From our last video on circular motion, you might remember that you can find the velocity from the period and the radius with the relationship v equals 2 pi times the radius over the period. We already have the period given to us, but we need to find the radius of the orbit. We know that the satellite is 700 kilometers above the surface of the Earth, but we also need to take into account the radius of the Earth itself, since it is the center of our circular motion. Thus, our radius is equal to the radius of the Earth plus 700 kilometers. And since the radius of the Earth is 6,371 kilometers, this will come out to 7.1 times 10 to the 6th meters. Now we do have the period given to us, but we need to convert it into seconds. Right now, we have that the period is 100 minutes. So to convert this to seconds, we need to divide by minutes and put seconds on top, and we know that in 1 minute there are 60 seconds. These minutes will cancel out, which means that t equals 100 times 60, or 6,000 seconds. And with these values plugged into our formula for v, we'll find that the velocity is equal to 7,435 meters per second. So we know our satellite has this constant orbital speed in the tangential direction. That means its orbital velocity is not changing, so the only acceleration is inward in the radial direction to keep it in its circular orbit. And just like in our last video, we can use the expression for centripetal acceleration, or the inwards acceleration, to maintain circular motion. This is equal to v squared over r, where v is the tangential velocity we found before, and r is the radius of our orbit that we found before. And when we plug in those values, we'll find that the acceleration inwards is 7.79 meters per second squared. If you found this video helpful, please be sure to like it and share it. And remember, you can book an online tutoring appointment with us right now through our Facebook page. Have a radical day.